Welcome to installment number 2 of our industrial robotics program. My name is James Swanson with Stiles Machinery, and today we come to you live from the field. Within today's activity, we will present to you 4 integrated machines, 1 industrial robot, integrated with 3 CNC machines. Within this system, the first set of real operator hands that touches the part doesn't happen until the component reaches the edge bander. So the manufacturing process here starts with the HOMEG StoreTech system, sometimes referred to as a storage retrieval or a material management system. Their sole goal within this system is to deliver the right material to the right machine at the right time, undamaged. Moving from the StoreTech to phase number 2, which is the machining center. Once the original raw panel is delivered by the StoreTech, the Sensitech receives that panel and automatically applies barcode labels to the raw panel. So we're part identifying before part processing. Once the identification is complete, the machine will fixture that raw panel and deliver it to the machine's matrix table. While that's happening, the StoreTech has delivered another panel to the machine, and we're pre-labeling the next part or the next nest in mass time, so a 0 cycle time process. Once that is finished, the finished parts will move out to an outfeed conveyor and present themselves to the next phase in the manufacturing process. We move from the nested machine into the industrial robotics segment of the production cell. So what you see here, the parts have been processed on the CNC. You can see parts on the outfeed belt awaiting to be transferred into the vision system of the robot. Over my right-hand shoulder, you can see the KUKA automation cell feeding parts into the dowel insertion machine. Working our way down today's manufacturing line presentation, we'll stop at position number 4, horizontal drill and dowel insertion capabilities within the cell. In this instance, HOMEG DrillTech D200 machine. As the robot picks parts from the nest, those that receive dowels are brought to the machine, oriented to the DrillTech D200 machine, and then the robot takes them away and exits them from the manufacturing cell. The robot has to be able to understand where the parts are on the outfeed conveyor. So within this system, we utilize an overhead vision system. The system will scan the parts and communicate with the robot, so the robot knows exactly what orientation the parts are on the outfeed belt, and it will work through its system to understand which parts receive dowels, which part do not, and make the appropriate decisions regarding where that part goes next. Those of you that are operating nested machines may kind of raise an eyebrow and say, how is that possible? What are you doing with the waste? What are you doing with the skeleton? What are you doing with the debris? In this particular situation, 2 things are happening. The optimization system is being utilized, in this case HOMEG's cut-right system, to strategically place waste cuts throughout the nest so that as the waste pieces remain on the outfeed belt, after all the good parts are removed by the robot, those small waste pieces are conveyed out of the system, and the pieces are made small enough so that as they tip off that incline belt, the cross-transfer belt takes those small pieces, drops them off into a Lima grinder. They're ground up into basically dust, sucked up by the dust collection and disposed of as waste material. The conveyor system here off to my right looks a little bit non-technical, but what's actually happening here is pretty high-end and almost brilliant. So what we're seeing here is we talk about the system operating a dowel machine. We talk about the system conveying parts out to an edge bander. But what about parts that don't receive either one of those things, right? They need a place to go within the system and not bottleneck the downline process. So this is I call a tier 2 level conveyor system where parts that don't receive dowels or don't receive edge banding are exited from the cell, allowing the consistency to remain in the manufacturing operation while we provide the operator to deal with this part on his own time. We got a pretty cool view here for you from a downstream view of the entire system. You'll see both single layer and multi-layer parts coming out through this conveyance system, both doweled parts and non-doweled parts that will come off the machine. And this is the first situation within the demonstration today where an operator hands touch the part. So as we move to conclude today's event, let's ask and answer the question that many people will have, which is why? Why was this system created? Why does it exist? And why does a manufacturer such as this one make the investment in the technology? The simple answers are faster throughput and less dependence on direct labor. The most important piece of why this system exists, it's the consistency piece. We need to ask ourselves the question, how does this make me more efficient? How does it decrease my dependence on direct labor? And how does it handle the inconsistencies of my manufacturing process?